Okay, see Lindelof videos, calculus, implicit differentiation, practice number 3. If you just looked at number 2 and you're like, that dumbass didn't do 2 problems, this is the one I was supposed to do, so I'm gonna go ahead and do this and try to catch up. So I apologize for being a dumbass. Here we go. So we're going to differentiate this function, this equation implicitly. And this is how we're going to do it. It looks like this. You kind of always think chain rule when you do this. So first off, I'm going to declare that I am going to take ddx of this whole thing. And by saying that, it looks like I'm saying I'm going to distribute the ddx, but I'm just saying that I intend to take the derivative of all 3 parts one at a time. So I'm going to do that by taking the derivative of the left side first. And it kind of starts out like this. It's really straightforward. You kind of have to look at it like this, though, as if you have a chain rule problem. So the outside part is what's in orange here. So I'll do 2 times 5 is 10, right? And it was 10y, right? Because y is the inside piece. And then I decrement the exponent by 1, so 2 minus 1 is 1. However, you do have to go back and take the derivative of the inside piece, and that's this y. So what is the derivative of y with respect to x? Well, it is the derivative of y with respect to x. So that's the notation that we're going to use here. I'm going to go over to the right-hand side here. This is actually real simple. This is just power rule, isn't it? So 3 times 2 is 6. Decrement the exponent. 3 minus 1 is 2 squared, right? Same thing here. Now I'm going to look at this, right? And if this was negative 5x, you'd say, well, the derivative of negative 5x is negative 5, right? But because this is not x but y, then you have to take the derivative of the inside piece. So you have to take ddx of this inside piece. And ddx of that is, well, dy dx. So I hope this is making sense. It's not super hard. You just have to practice it and remember that everything kind of looks like the chain rule here. You will hopefully notice that we have dy dx on both sides. So I'm just going to do a little bit of algebra here. So I'm going to get my 10y dy dx. I'm going to add 5 dy dx to both sides, so plus 5 dy dx. So you see I'm getting all my factors of dy dx on one side or the other is equal to 6x squared. The reason I'm going to do that is because I'm going to factor this out, right? So I am going to go ahead and factor this out right here, and I'll factor out dy dx here, dy dx here. So there's my dy dx, right? And what we are left with on the inside is 10y plus 5 is equal to this crap right here, right? So equals 6x squared. And now, of course, the goal is, right? The goal is to get this thing by itself. So I'm going to divide both sides by 10y plus 5. So dy dx is equal to 6x squared over 10y plus 5. So hopefully that's good. Remember, of course, what the idea is here, especially when you see this on the AP exam, they're not going to say this is an implicit differentiation problem. What they're going to say is find the derivative at a point, and you're going to look and go, holy shit, what is that mess right there? And you're going to realize I have to differentiate implicitly. And as you do that, remember, they're going to give you this point, x, y, right? They're going to give you these numeric values. And when you do, this value goes here. Obviously, please don't think I'm being an ass, and this one goes here, and that's the way you get a numeric slope value back, right? So, hey, I hope this is helpful. If you have any questions or comments, please let me know. The exam is something you can do really well on, so if there's something I can do, please let me know. If you haven't already subscribed, will you please? Thanks.